Hey everyone, can you believe it? We're in week 2. So this is week 2, Calc 1, Day 6, Lesson 13, Chapter 2, Section 5. Okay, today we're going to talk about the chain rule. Okay, so the chain rule formally looks like this. So it has f prime of x, and it uses a capital F prime because, as you see in the definition, it'll have the little f prime of g of x and then times the derivative of g of x. So let's talk about what this means for a minute. What this means is you're going to take the derivative of the whole entire function, the outside of it first. After you take the derivative of the outside of the function, then you're going to look inside the function and take the derivative of this. In my mind, I always see it kind of going like this. I don't know. That's kind of how I think of it. So I take the derivative, come around, and take the derivative. So let's do a couple examples. Now again, the only reason they're using the capital F prime of x is because in the definition, little f prime of x is in there, but you don't even really have to use that notation. We have the square root of x squared plus 1. Okay, so first let's think about what this means. So this actually means x squared plus 1 to the half power. So if we're to take the derivative of this using the power rule, we would multiply by 1/2 and then subtract, right? So let's do that. So we're going to have 1/2, whatever's inside, doesn't matter what's inside right now, and then negative 1/2. So that's what this part means, that you just take the derivative of the whole thing on the outside, okay? Then after you're done with that, you got to go back inside, okay? And I guess my swirl should be more like coming inside like this instead of on the outside. So maybe like this might be a better visual of it. I just know my brain starts swirling when I do this. So anyway, so we have 1/2 x squared plus 1 to the negative 1/2. Then I look at the inside and I take the derivative of just what this is. I don't pay attention to anything on the outside anymore, and I take the derivative of this, so I get 2x, and the plus 1 goes away. And that's it. So, well, we do have to clean it up. We want to make it look nice. Okay, so we're going to reduce. I have x is going to be on the top. The negative 1/2 will bring my radical to the bottom. And there's example 1. Okay? That's example 1 on page 149. Okay, let's now take a look at, let's see, example 2. Differentiate y equals sine x squared and y equals sine squared x. So we want to look at the differences. Okay. All right, these two things mean something completely different. The first one, if we differentiate this as we go across, we just say what's the derivative of sine and its cosine. We leave this alone, and then we differentiate the x squared. So that's 2x, but just make sure you don't write it so it's after the sine or the cosine to confuse that it's part of this, because this will come on the outside, and that'll be your answer there. Okay? Now, if I have over here The difference is that this is sine x to the second power in this notation, okay? So in order to do that, I'm going to use my chain rule, multiply 2 sine x, and then I subtract to the 1 power, okay? So I don't even really need to put that here. And then differentiate the inside. The derivative of sine is cosine x. So the final answer for this would be 2 sine x cosine x. Okay? And that's the difference between the two of those. All right. Let's continue on. Example 3. And I'm on 151 if you're following in the book. Y equals x cubed minus 1 to the 100th power. Okay, so again, y prime, bring the 100 down, write the inside unchanged, subtract 1 from your exponent, and now go in the inside. So it's 3x squared, and the minus 1 goes away. So when we simplify this, we're going to bring this out and multiply it. Again, at the end, we always want to clean it up. Put the x squared out front, and then x cubed minus 1 to the 99th power. Okay? So far, so good. Let's look at example 4. On the same page, my f of x is equal to 1 over, take a look at this exponent they have there. We have the cube root of x squared plus x plus 1. Now this one could be a little tricky, but if you put it in using the exponent, it's always so much easier to do. So we have x squared plus x plus 1 to the 1/3, since it's a cube root. It'll be to the 1/3 power, okay? Oh, negative, I'm sorry. Negative because it's on the bottom, remember? So now f prime of x, multiply negative 1/3 x squared plus x plus 1. Subtracting 1 from this, remember, is subtracting 3/3. So this will be negative 4/3. Okay? And then after we do that part, we're going to differentiate the inside. And we'll get 2x plus 1. So, clean it up. This is going to go on the bottom. The 3 is going to go on the bottom. These are going to go on the top. I can put the negative out here, or if I put it here, I have to put parentheses or distribute it. And this is really 1 1/3. So that means I'm going to have one of these on the outside. And then a third left. Okay? So this would be a good final form. All right. Example 5. Still on page 151. We have g of t and t minus 2 on the top, 2t plus 1 on the bottom, all of that to the 9th power. Okay, here we go. Okay, so we're going to do the outside and then do the inside. So yeah, so outside, then inside. Okay, all right, so outside is 9 t minus 2 over 2t plus 1 to the 8th. And now the inside of this is a quotient rule. Should have left myself a little bit more room, I think. So we have 2t plus 1 on the bottom. That is what we're bringing up to the top. Multiplied by the derivative of this. Now the derivative of this is just going to give me 1 because the 2 is gone. Minus, again, quotient is minus. That's why order is so important. Derivative of, well, we'll leave this one alone. We'll put this first. Be consistent here. And the derivative of the bottom is 2. Okay, now that's definitely going to need some cleaning up. So let's take a look. I'm going to move it over this way a little bit. We still have our 9 times t minus 2 over 2t plus 1 to the 8th. And over here, let's multiply this through. That's just times 1, so it stays the same. This I'm going to multiply by 2 and distribute the negative. So negative 2t plus 4. And the bottom is still, excuse me, 2t plus 1. Still got this cold. All right, so gone, gone. All right, now 1 plus 4 is 5. This is squared on the bottom. We have a 9 out here, which will multiply by the 5. And I want to point something out first. Now, this is all to the 8th power. So since it's to the 8th power, that means that this is to the 8th power and this is to the 8th power. So if I put it over here, it looks like this. So since I have 8 here and 2 here, that means my final answer, I'm going to have 10 on the bottom. Nine times 5 is 45. And there is my answer. Not too bad. Just take your time. Alrighty. More examples. Let's go to example 6. Y equals 2x plus 1 to the 5th I have to get my reading glasses out, and x cubed minus x plus 1 to the 4th. Okay, so here we have it. This is a lot, so we're gonna have to leave some room. This is a product rule and a chain rule here and a chain rule here, so we really got to take our time. So let's just start with this one, because product rule, we don't have to worry about what order we start in. Five times 2x plus 1 to the 4th. Now I don't stop there. I go on the inside, times 2. Okay, the 1 is gone. So that is my derivative of the first. Now I'm going to leave this part alone. Okay, so that's my first part of my product rule. The second part, I want to differentiate this. So I'm going to have 4 times x cubed minus x plus 1 the third, differentiate the inside. Now 3x squared minus 1. And then I add on my 2x plus 1 to the fifth. Now, those of you that like puzzles and things, you'll start liking these. Just think of it as a game. So here I have 10. And over here is just 4. I'm going to move my 3x squared minus 1 out here since it's single. I'll put my 2x plus 1 next. Keep it in order with the other one. Not that it has to be, but gives us a little better visual. Okay, now you say, oh, are we finished? Well, not really. So what we have to do is we need to look at what is the same in both of these and factor. Whoop, I forgot to put plus. Bad mistake. Okay. What is the same in both of these, and then pull it out and see what's left. So you can see we have at least 4 of these in both. So I'm going to be factoring out 4. I guess I should look at my constant too. So I have 10 here and 4 here. A 2's in common, so we can factor out a 2. And finally here, I have 4 here and 3 here, so I have at least 3. Now, what's left? Let's see. 5. 1 more of these, because I only took 3 out, so there's 1 left. Plus 2. I still have this. And I took 4 of these out, so I have 1 of these left. And I took all 3 of these out. Okay, so now I have this. Now, let it distribute here through. I'm going to make this 5x cubed minus 5x plus 5. I need to FOIL 6x cubed plus 3x squared minus 2x minus 1. Okay. And then multiply my 2 through. All right, let's see if we can combine anything. Looks like we have 17 x cubed 6x squared negative 9x and minus 1. Oh, wait, let me double check that. I made a mistake somewhere. Can you find my mistake? Let's see, we're going to multiply this. I have a plus here. I'm going to pause. Okay, so here's the 5 times the 1 is 5. So positive 5 minus 2 is 3. Okay. Now, this doesn't simplify anymore, and I'm going to bring the rest of this down. And here we go. with our answer. This is the preferred form, not this. So if you wonder, well, do we have to do that? Then yes, you really do, because this is the preferred form and it helps if you're going to be moving on to the next step. Okay, next one, example 7. Sine, cosine, tangent, x. All right, now we're going to differentiate this. Okay, so I have sine of this whole thing. So I'm going to have to take cosine of the whole thing, because the derivative of sine is cosine. And then I'm going to differentiate the inside, which is the cosine of tangent x. So that would be negative sine of tangent x. And then I want to differentiate the tangent x, and that would be secant squared x. Okay, so let's clean that up. We know it's negative. And don't forget, like this is one term, so we can't like multiply these together or anything like that. So we have negative, let's stick that secant squared x out front first, times cosine of tangent x, and then sine of tangent x. All right, let's review that, make sure I have it right. Okay, negative secant squared, cosine tangent x, sine tangent x. Yes. Okay. Well, that one's a little bit confusing, but you can do it. Really only a one-step problem and then clean it up. Example 8. I have y equals secant x to the third. Okay, remember this is secant x to the third to the 1/2 power. And that's how we want to differentiate it. So y prime is 1/2 secant x to the third to the negative 1/2. And then I'm going to differentiate secant. And when I do that, I get secant tangent. So that would be secant x cubed tangent x cubed. And then finally, I'm going to differentiate the x cubed, so that's 3x squared. And I purposely write that bigger again because I don't want it getting lost inside here. Okay, clean it up a little bit. I have my x squared on the top. I have secant x cubed tangent x cubed, and then on the bottom I have my square root of secant x cubed on the bottom. Okay, let me look at that. It all looks good. So in this one, we're doing chain rule, chain rule, chain rule. So we go around, do it again, and then do it again. Okay? All right. Now, let's see. We're not going to worry about how to prove it, and that will be the end of section 2.5. So, like I say to all my kids, peace out, and I'll see you next lesson in a few minutes.